Okay, so in this video, we are going to discuss the May June 2023 paper 6.1, which is statistics 2. All right, so let's look for the very first question. Okay, we have in a certain country, there's this number of adults out of a population of this have a degree in medicine. All right, so we know that this is something like X over the total of the population, and we can actually get the proportion or the percentage of the people or the adult with a degree in medicine for this country. And then for part number A, they are saying that use an approximating distribution. So the keyword is approximating to calculate the probability that in a random sample of 1,000 adults in this country, there will be fewer than 4 adults who have a degree in medicine. All right, so let's analyze first. For approximation question, right, in A2 syllabus for stats 2, basically there are a few. So the first one is we are actually having binomial distribution become Poisson. So maybe I write it like this, binomial become Poisson. That's the first one. And then we also have the second one where we are having Poisson distribution and we can change it become normal distribution. So these are the two possible approximation that we have in our stats 2 syllabus. Okay, and then let us have a look at which is a possible approximation that we can use in this question. If we have a look for the information given here, we are having this number of adults with a total population in this value. So from here, I can actually get the proportion. And a sample of 1,000 here, right? So the 1,000 here should be the n. When we are having the n and also the p, basically we can have a binomial distribution. So that means originally for this question, it should be binomial distributed. And after that, we can change it become Poisson according to the certain criteria, right? So for this question, we are using binomial to Poisson instead of Poisson to normal. So we are having binomial originally, and we want to change it become Poisson to answer the question. All right, so let us set up a question first. Okay, so originally I'm having binomial distributed, and then the n is 1,000, and what is the proportion here? So the proportion should be 20540 divided by the total of the population. So please take note that to ensure that my final answer is accurate, I will generally keep it into a fraction form. I didn't change it become the decimal number, right? So I will just keep it as a fraction form. So this is my original binomial distribution, and then according to a certain criteria, right, we can change it become Poisson. Okay, so how to change it become Poisson? To get a lambda, I have to take n multiplied with p. So this is basically the n in binomial distribution, and this is the p. To get the lambda or the mean for Poisson distribution, it will be n multiplied with p. So if I take n multiplied with p, maybe I can make this shorter. Okay, so to take the n, multiply with p, I will get the lambda basically, which is equals to 3.42, correct, to 3 significant figure. Alright, so of course, if you want it to be more accurate, you can keep your lambda as long as possible so that later you can get a more accurate answer. So to get the lambda, it is equals to n multiplied with p. So for you to recall back, right? So how are we going to change the binomial become Poisson? Okay, then they want us to calculate the probability. Okay, calculate the probability that fewer than 4 adults who have a degree in a medicine. They want us to calculate the probability of the number of people or number of adults who have a degree in medicine is less than 4. Fewer than 4 means less than 4, right? Okay, so now we have to use Poisson formula to calculate the probability here. Okay, so before we start, let us analyze again. What do we have here? For binomial distribution, it is a discrete random variable. And then for Poisson distribution, it is also a discrete random variable. Therefore, no continuity correction is needed for this approximation, right? And I can straight away calculate the probability, right? So to get the probability for x smaller than 4, the formula will be E negative lambda. So E negative 3.42. Then the first number is 1, always a 1. the second number is always lambda. Then the third number will be 3.42 square, the lambda square divided by 2 factorial, and then the lambda cube divided by 3 factorial. Okay, and then just for your information, right, this is actually when I take E multiply with this one, this probability is actually the probability of x equals to 1. And then when I take e power negative 3.42 multiply with this 3.42, it is actually the probability of x equals to, oh sorry, I made a mistake here. So sorry for that. It is x equals to 0, and then this one is x equals to 1. Then if I multiply the e power negative something with this phrase, it is actually the probability of x equals to 2. And if we continue this will be x equals to 3. All right, and then for this question, they are asking for the probability of x smaller than 4. That means not included the 4 here. Therefore, I should stop at the probability of x equals to 3. Okay, so this is a simplified formula to calculate the probability for Poisson distribution where x is smaller than a certain number. Okay, all right. Then after that, just make sure that you press calculator carefully and don't do any careless mistake. By right, you should be able to get a final answer where it is 0.555 correct to 3 significant figure. So this is how basically we answer the first question, part A. Alright, then now let's proceed to part number 2. Part B, sorry. So for part B, justify the approximating distribution used in part A. So they want us to justify how are we going to change the binomial become Poisson. There are some certain criteria that we need to fulfill, right? Okay, so for your information, this kind of question you need to memorize, right? You need to memorize it. Okay, to change binomial become Poisson, there are two criteria that you need to follow. The first one will be you have to ensure that n is greater than 50. Okay, then in our question, here, we know that our n is more than 50 already, right? Because our n is equals to 1000. Okay, and after that, the second criteria to fulfill is your n times p must be smaller than 5. If we try to double check the n times p for our question, we get actually 3.42, and it is also less than 5. Therefore, for this question, because our data fulfill these two criteria here, and we can change the binomial become Poisson distribution. Okay, so we come to question number 2. We are given a diagram here, a graph. Okay, so it shows the function f is a straight line segment from 0, 0 to 2, 1. Show that f could be a probability density function. Right, so they want us to show that f should be a probability density function. Right, to fulfill the criteria of the probability density function, right, basically there are two also. The first one is the function must be positive. All right, and the second one is the total probability, which also means that the area under the graph should be equals to 1. These are the two criteria to make sure that one of the this particular function belongs to a probability density function. Alright, so these are the two criteria that we need to double check to show that it is a probability density function. Okay, so for the first one, how are we going to ensure that the function is positive? Basically, this question is very simple. You just need to have a look for the graph here. The graph of fx, if it is above the x-axis, that means it is positive. Because this part is y positive, right? Then below the x-axis will be negative, right? So when we look at the diagram given, we can see that our function, the graph that we have is above the x-axis. Therefore, it is a positive function. So we can write it like this. So function fx is positive for the x defined. So as a meaning for x defined. So if you have a look for our diagram, right, the graph start from 0 until 2. So that means within this defined x, right, the graph is above the x-axis, which means that the function here is a positive function. Okay, and then secondly, we need to check and see, is it the total probability equals to 1 or not? Alright, so to calculate the total probability, That means it is equals to the area under the graph. Where is the area under the graph? So my graph is basically a triangle, and then the area under the graph means I need to calculate the area of this particular triangle. So the triangle area will be half multiplied by base. So the base is actually 2 unit, right? And multiply the height. So the height is 1. And you have equals to 1. Okay? So you can see that for this particular function here, it fulfills two criteria that it need to be the probability density function. So since it fulfills, so you can say that f is a probability density function. Okay, so this is what you need to know for a continuous random variable. Alright, then now let's proceed to part number 2. For part B, they give us another diagram and it is the function g. So the graph of the function g is a semicircle, center 0, 0, entirely above the x-axis. So again, you can see that the gx is positive, is a positive area, a positive function. Given that g is a probability density function, so you can see that g already fulfilled the first criteria where it is above the x-axis. That means g is positive. So from here you know that g is positive. So the first criteria has been fulfilled. Now they mentioned that g is a probability density function. Find the radius of the semicircle. So from this keyword here, we know that G also fulfill the second criteria. So what is the second criteria? That means the area under the graph should be equals to 1. Right, so I can write this one. The second criteria will be area under the graph should be equals to 1, which means it is a total probability. Okay, then now, let's have a look. It is a semicircle, right? And then the center is 0, 0. If I assume that this is the R, the radius, right? How to write out the area for a semicircle? So the formula for the area of a semicircle will be half of pi r squared. And I know that it is equals to 1. Therefore, the r squared should be equals to 2 over pi. And the r will be equals to square root 2 over pi. Alright, so since they asked us to find the radius, so radius is r, so I only consider the positive value for the r. Okay, and you can leave your answer like this, square root 2 over pi, or you can change it become the 3 significant answer, which is 0.798. So there are 3 significant figure. Okay, so you can see that for part A and part B, right, they are actually testing your understanding about the criteria of a probability density function. Alright, so please make sure that you know these two main criteria here. Alright, then now let's proceed to the next part, part C. And now we are having the other diagram here, and it is actually the function h. Okay, then they are telling us that the time in x minutes taken by a large number of students to complete a test has a probability density function h. So you already can see that they tell you this is a probability density function as shown in the diagram. Without calculation, use the diagram to explain how can you tell that the median time is less than 15. Okay, so let's say this is 10. By right, 15 should be somewhere here. Okay, so they are saying that why the median time, right, is less than 15 minutes. So that means the median is not 15, it should be less than 15. It is between 10 and 15, it will be less than 15. So what is the reason? Okay, or how to explain that the median is less than 15 minutes. Okay, so for your information, we need to know another info, or maybe another useful fact for probability density function, where when you integrate from the lower limit, lower limit, okay, of that probability density function until the median, okay, it should be equals to 0.5. That means when you start from the lowest range, the lowest limit, okay, for the function until the median, the area should be equal to 0.5. Okay, but if you have a look for this diagram, right, the diagram is actually higher on the left hand side, therefore you will reach 0.5 earlier than 15, correct or not? Because very likely you are having the 0.5 here, because the area is larger at the beginning and then the area is smaller at the end. Alright, therefore you can see that to reach the 0.5 area, by right it should be before 15. Okay, so to tell them about this, you can write it like this: the area to the left of 15 is more than 0.5, which means I'm saying that if I try to consider the area from 10 until 15, right, this particular area definitely is more than 0.5, or the 0.5 might reach earlier before the 15. Okay, so if let's say this is 0.5, then this is a median, and from here you can see very clearly that the median should be less than 15. Okay, so this is how we verify it. And next one. Now they give us a function hx in term, the formula, right? And they also stated clearly that it is defined from x equals to 10 until x equals to 20 inclusive. They want us to calculate the mean. Right, so to calculate the mean, what is the general formula for the mean? Okay, to calculate the mean, you should apply integration from the lowest limit to the upper limit, okay, of the function. And then before you get the mean. Before you want to integrate, right, you have to take x multiply with fx. That only you can integrate. It is because of mean means expected value of x. Okay, so because of you're having the x here, when you want to integrate and get the answer, right, you need to multiply it with the x. So this is your general formula to get the mean. Alright, so we can start from here. To get the mean time, basically I need to integrate from 10 until 20, multiply the x into the function hx. Okay, so before I can apply the integration, of course, I need to multiply the x inside the function, right? Okay, so I'm having 40 divided by x, then minus 1 over 10 multiplied with x. Okay, so integrate 40 over x, I will have 40 ln x. All the integration technique, you need to revise your chapter 5 in paper 3, which is about integration. Integrate 1 over 10x, I will get x squared divided by 2, right? So I become x squared divided by 20. And I have to substitute in the limit 20 and 10. Okay, therefore, if I substitute the limit inside, I'm having 20 squared divided by 20, then minus 40 ln 10 minus 10 squared divided by 20. And again, if we try to press calculator for the value, we should get a long answer, which is 12.72588,722, and then we are having 12.7 as a final answer, correct to 3 significant figure. Okay, and then for this question, right, because they didn't mention clearly that they want the exact mean time, therefore we are allowed to straight away get the limit, get the final answer by pressing calculator. Okay, if they want us to express it in exact time, then we have to simplify the term here. Alright, so luckily it is not, so we can straight away press calculator and get the final answer into 3 significant figure, which is 12.7. Alright, so this is how we answer question. Okay, so now we are at question number 3. For this question, they are telling us that in the past, the annual amount of the wheat produced per farm by a large number of similar sized farms in a certain region has mean 24.0, and the standard deviation is 5.2. Then last summer, there's a new fertilizer was used by all the farm, and it is expected that the mean amount of the wheat product produced per farm will be greater than 24. In order to test whether this was true, okay, so I think we can see a keyword here, test. A scientist recorded the amount of wheat produced by a random sample of 50 farms last summer. So he found that the value of the sample mean was 25.8. So stating a necessary assumption, they want us to carry out the test at 1% significance level. Okay, so for this question, of course, the keyword will be the test. It tells us that it is a hypothesis test question. And then what kind of value or data that we want to test. So if we have a look here, we are having mean 24.0, okay, where it denotes the population mean. And then we are having this value, standard deviation is 5.2, we are having the population variance. Okay, oh sorry, population standard deviation, that means the population standard deviation is known. And we have the keyword greater than. And after that, if you have a look in further, right, further, so we are having this, a sample of 50 from, we have the n. And lastly, we are having this sample mean. So sample means x bar, and the sample mean will be 25.8. So from all the information given here, right, although they didn't mention that it is a normal distribution, but we know that since the sample size is large, therefore when you want to carry out the test, we can assume that it is normally distributed. And after that, for this sample mean, right, they actually tell us that we are going to use this sample mean to calculate the test statistics in our solution. Right, so from here, we want to test the changes in the population mean. Okay, so first of all, we need to set up the test first. Okay, so first we try to state the necessary assumption first. So to carry out the test, right, although we are having this sample mean, we are going to use this sample mean to carry out our test, but you have to assume that the standard deviation, okay, remain the same for the sample. All right, because later we are going to use the standard deviation to calculate the test statistics. Right, so we are having the population, and this is the population standard deviation. So to carry out the test, right, you have to assume that the sample mean, this sample is actually having the same standard deviation with the population. Right, so the assumption will be, I will write the assumption here. Okay, so the assumption will be, assume that the standard deviation remain the same or still the same. Okay, where we are having the so sigma equals to 5.2. Okay, all right, then after we state the assumption already, now we need to carry out the test. So first of all, we need to set up the null hypothesis and also alternative hypothesis. Okay, what we are going to test is, we are going to test about the population mean, whether is it greater than 24.0. 24.0 is the normal value that we have, and then we want to test whether it become greater than, the keyword is greater than 24. So the keyword greater than is to help us set up the alternative hypothesis. All right, okay, so I want to set up the question now. The null hypothesis is mu equals to 24.0. And then for my mu, under the alternative hypothesis, we want to, by looking at the keyword are greater than, so we want to test whether is it greater than 24.0. Okay, so from here, we can see that it is actually a one-tail test, because you can see that our alternative hypothesis is greater than, that means right-hand side, it is a one-tail test. Okay, so we already set up the alternative and null hypothesis. So please take note that the symbol that you use here should be a mu, which is a population mean. You cannot just stated that it is just a normal mean, right? Mean. It is actually a population mean for all the farms. Okay, and so for the next step, after we set out the null and alternative hypothesis, so for the next step, we can try to find out the critical value. Okay, for this test, I'm going to use the normal distribution. It is because of the sample size given in the question is a large sample. So although we don't know what is the original distribution for the population, but since the sample size is large, therefore we can assume that the sample mean is normally distributed. Right. Okay, so to carry out the test at 1% significance level, I want to carry out the test by using critical value approach. So first of all, I want to find out the critical value. So at 1% 1% significance level, right, is the value of Z. What is the Z value at 1% significance level? So basically, if you want to have a look, right, the diagram should be something like this. If I draw a normal distribution graph, because we are having one tail test on the right, therefore my rejection region will be on the right hand side. So I simply draw a rejection region on the right hand side first, and it means that this particular area is 0.01. Okay, to calculate the critical value at this part, we need to find out the value from our normal distribution table. Right, so what is the critical value here? Okay, so the critical value for this part, you have to refer to this 0.99. Okay, that means you have to assume that Z smaller than the critical value is equals to 0.99. So I go to our normal distribution table, looking for the area 0.99, you'll get 2.326. Right, so if I go back, this critical value, sorry, I should write it as critical value here. The critical value here should be equals to 2.326. Okay, all right. And it actually means that if I want to denote it by using the diagram, right, this is the critical value, and this particular value is 2.326. And any value on the right hand side of 2.326 will be the rejection region already, will be fall in under the rejection region already. Okay, so after I found the critical value, next step, I'm going to find out the test statistic. Okay, so to calculate the test statistic, all right, what is the general formula that we have? We are having the sample mean minus the population mean divided by standard deviation over square root n. And you can see that we are having all the values here already from the question. So I'm having 25.8 minus the population mean 24 divided by standard deviation. We just not assume that standard deviation is still having the same value, right? So 5.2 over square root n, so square root 50. From here, the test statistic that we get is actually 2.448. Okay, then now after we calculate the test statistic, we will want to decide what is our decision for this test. Okay, 2.448, if I try to put it inside this diagram, okay, you can see that it should be more than 2.326, right? So that means that it will fall under the area, the rejection area, where it is 2.448. So I think it is quite obvious that you can see that the 2.448, the test statistics falls under the rejection region. Okay, so to make a decision, of course, we need to write out the criteria that we decide first. So test statistic, okay, we can make a conclusion like this. We can decide it like this. Test statistic is equals to 2.448 and it is greater than critical value. Critical value, which is equals to 2.326. Right, and of course from the diagram here, I can see very clearly that 2.448 falls under the 2.326. Right, so when it is under the rejection region, this area we call as rejection region, right? Since the test statistic falls under the rejection region, therefore I can make a conclusion or decision where we reject the null hypothesis. Okay, so if you reject the null hypothesis, means that the alternative hypothesis is true. So you need to make a conclusion according to the context of the question. Alright, so alternative hypothesis is true. That means you can make a conclusion like this, where there's enough evidence to show that the new fertilizer actually really increase, right, the farm's production, right or not? So we are saying like this. So the fertilizer increase the farm's production. Alright, so this is how we answer the question number 3 lah. How to carry out the test to test the population mean. Okay, so at question number 4 now. There's a certain train journey takes a place every day throughout the year. So the time taken in minutes for the journey is normally distributed. So maybe you can highlight the keyword normally distributed with the variance 11.2. Okay, then we are talking about the time taken for the train journey lah. Right, so the mean time for a random sample of n of these journeys were found. And then 94% confidence interval for the population mean. Okay, for the population mean time was calculated and was found to have a width of 1.4076 minutes, correct to 4 decimal places. So first they want us to find the value of n. Okay, so for this question, before we can find the value of n, let's have a look at what is the information provided here. So they tell us that we are having a 94% confidence interval and it is having the width of 1.4076. Okay, so for confidence interval of population mean, right, the general formula is actually x minus z sigma over square root n. Then the upper limit will be sample size, okay, plus z sigma over square root n. This is the general formula for the confidence interval for population mean. And then what's the formula for the width? So to calculate the width for the confidence interval, we are taking the upper limit minus the lower limit. So the width is actually upper limit minus the lower limit. Therefore, you will get the general formula, okay, minus z, that's sigma over square root n. And by right, when you simplify everything here, you should be getting 2z sigma over square root n. And this is the general formula for the width of a confidence interval. Okay, and of course, the z value here will be depends on the percentage, the confidence level of the confidence interval. Okay, and this is the formula that I'm going to apply. So in the exam, you can straight away apply this one without proving it. Okay, so the formula for the width of a confidence interval is basically this one. Right, so let's start. Since I know that the width is equals to 2z and then sigma over square root n. Okay, so from here I know the value for the sigma, right? Because it is the standard deviation. I have the variance for population already. And then for the n, it is something that I want to find. Then for the width is 1.4076. So now I still need the value of z. Okay, so to get the value of z, again, we need to refer to the normal distribution table. But before that, we need to try and imagine what is the value of z that we can find, okay, from a 94% confidence interval. So when they mention about 94% confidence interval, it means that on both sides, we are having a same area, and the 94% denotes the center area for the diagram. So I'm having 0.94 here. That means to make it balance and total up become 100%, right? This should be 0.03 and this one should be 0.03. And the value of z is actually this value of z. And to find out this value of z, I need to consider the area that is smaller than this z. So you can see that the total area here is actually 0.94 plus 0.03. So the total area that you should consider is 0.97. Which means that to find out the value of z, we need to use the table, okay, to find the table in a reverse way, okay, to get the value of z by using the probability of 0.97. Okay, so we go back to the table here. If I want to look for 0.97, right? So first we look for the value smaller than 0.97, okay, and it's closer to 0.97. So from here, I think I can see this value which is 0.9699. So 0.9699, I need to plus 1, okay, to get the 0.97. So if I want to read the value of z from the table, then you can see that it is equals to 1.8, 1.88, and then 1. Alright, so some students might say that can I use 1.882 or not? Basically, okay, can, right? Because these two will give us the same value, which is 0.97 for the probability. Right, so I can use either one, 1.881 or 1.882. Okay, so from here, I already know that my value of Z is 1.881. Of course, you can use 1.882 also, no problem at all. Alright. Okay, then now I want to substitute all the value in. My width is 1.4076. And then 2 is a 2. Z is 1.881. Sigma will be square root of 11.2. And the sample size is actually n. And I don't know what is the value of n. Okay, so by moving all the values here and there slowly, by right, you should be able to get the n, which is equals to 80.00130821. So correct it to 3 significant figure. The sample size that we have for this is actually n equals to 80. Okay, so before you answer the question, of course, you need to know what is the formula for the width of a confidence interval for population mean. That's the first thing. And the second thing is you need to know how to get the correct value of Z for a certain percentage, the certain confidence level for the confidence interval. Right, so this is how we answer question number 4A. Okay, then let us proceed to part B. Okay, so for part B, they're asking, there's a passenger noted the time for 50 randomly chosen journey in January, February, and March. So by using the sample from these 3 months, right, they are saying that why the sample is unsuitable for the use in finding a confidence interval for the population mean time. All right, so when you want to use any sample, right, it will be good if the sample is random enough. Okay, so for this passenger, they actually only focus for the 50 randomly chosen journey or sample in these 3 months only. Okay, so to me, it is not random enough. It is because of when they only focus on the first 3 months. Okay, it cannot, we cannot use it to represent the whole year, because maybe when, how to say, for different month in a year, all right, the train journey might take different time, because maybe when the weather is bad, then the train might travel in a slower, okay, will take a longer time to travel. Or maybe when the weather is good throughout a certain year, maybe during summer or what, then the train journey might be shorter, right? It can travel faster. Therefore, by considering only the sample from first 3 months is not the suitable one. Okay, so we can say something like this. So the January, February, and March, okay, are actually not sufficient to represent the whole year, to represent the data, okay, or the train journey for the whole year, to represent the whole year. Okay, and then the weather might be different, okay, that will affect the time taken for the train to travel, might be different, okay, at different time of the year. Okay, all right, so this is how we answer question number B. Then we proceed to part C. Okay, for part C, now we have another researcher took 4 random sample, okay, and a 94% confidence interval for the population mean was found from each sample. So that means I'm having now 4 confidence interval, okay. So they said 4 random sample and every single sample I calculate a 94% confidence interval. So that means now I'm having 4 confidence interval, right? Okay, so find the probability that exactly 3 of this confidence interval contain the true value of the population mean. Okay, so we need to know for a particular confidence interval, right? What is the true value? What is the percentage of the confidence interval contain the true value, okay, of the population mean? When you're having 94%, right, it actually means that we are having 94% confident that the population mean is inside the confidence interval. So when they say the confidence interval contain the true value of the population mean, it means that this one is having the probability of 0.94. And now they're asking, out of the 4 random sample, I want to know what is the probability of 3 of the sample is having the population mean in the confidence interval. So you can see the structure of the question here. I'm having 4 sample and 3 of them something happened, right? And this is basically a binomial distribution question. If you want to look at it by using binomial distribution, so basically it's binomial distributed, and then I'm having 4, and the p should be 0.94. Okay, let's say this is x, and they actually want us to calculate the probability of x equals to 3. So if we apply the binomial distribution formula, it will be 4c3, then p power 3, and then q power 1. So q means 1 minus p lah. I'm having 0.06 power 1, and from here, you'll get a long value. So you press the calculator, and of course, we have to cut it short into 3 significant figure, where we should put it as 0.199. Okay, so for this question, you need to aware how to identify as a binomial distribution question. Or maybe some students, they will say that they will try to consider maybe the first confidence interval contain the mean, contain the population mean, which is 0.94. Second confidence interval also contain the mean, which is also 0.94. The third one is also 0.94. And the fourth one do not contain the mean, which is 0.06. And of course, you need to consider the arrangement between these 3. So some students might say that this one is contain, 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 not contain, right? So to arrange this 4 sample here, it should be 4 factorial divided by 3 factorial, because the 3 sample contain the mean should looks the same, all right? Okay, they are identical, therefore they might be identical, therefore you have to divide it by 3 factorial. You can also do it in this way, but for me if let's say I want to answer this question in a more straightforward way, I feel that binomial distribution will be easier and more straightforward. Okay, so you have to learn how to identify a question that belongs to binomial distribution. Okay, right, so this is basically how we answer question number 4. Okay, so now we proceed to question number 5. There are large packets of rice are packed in cartons, each containing 20 randomly chosen packets. Okay, and then the mass of these packets are normally distributed, so please highlight it, and then with this mean and also the standard deviation. The masses of the cartons when empty are independently normally distributed again, with the mean 50 gram and also standard deviation 20. Okay, so they want us to find the variance of the masses of full cartons. So first of all, we need to know what is the meaning for the full cartons here. So full cartons are having 20 randomly chosen packets. Okay, so 20 randomly chosen packets. That means I'm having packet number 1, number 2, number 3, number 4, until 20 to put it inside the carton. Alright, so to calculate the variance for full cartons, okay, basically it's like this. Let's say I'm having the large packet, I make it as X. And then for the full carton here, for empty carton, okay, so for the empty carton, maybe I label it as E, let's say. Oh, sorry, don't use E lah. Maybe I use some other letter, maybe T. Okay, Alright, so to calculate the variance of the masses of full carton, for the full carton, we need to calculate the mass of the empty carton plus 20 packets. So it will be T plus 20x. And when they want us to calculate the variance, okay, so variance of T plus 20x, okay, so basically we are having the variance of T, that means the carton, the empty carton, plus 20 of variance for the x. Okay, so maybe we want to discuss about this. Why is this 20 but not 20 square? Okay, for this question, because we are having 20 randomly chosen packets, that means basically we're having 20 different packets in the carton. So to calculate the variance, right, it should be the variance for first packet plus the variance for second packet plus the variance for third packets and so on. So in total, we are having the variance for 20 packets. So the 20 here, we don't have any square. But if the question are mentioning that we are having the one packet only, but the weight is 20 times for a one packet, so the 20 here only you need to square it when you want to find the variance. Okay, all right, so that this is how we decide that we have to look at the keyword, okay, in the question. So you see 20 times, then when you calculate the variance, only you put a square with it. Right, so for the variance here, variance t, so what's the variance t here? Standard deviation for the empty box is actually, empty carton is 2, right? So the variance will be 2 square. Then plus 20 multiply with, what is the variance for the packets? So the variance for the packet is actually 3.4 square. So you multiply with 3.4 square. And from here, we should get the value, which is, let me have a look, 235.2. Alright, so this is how we calculate the variance for 20 large packets with the empty cartons. Okay, so let's proceed to part B. Now we are having small packets. So small packets of rice are packed in boxes. Just now the large packets are in cartons. Now the small packets are in boxes. So the total mass of full boxes are normally distributed. So again, you highlight the keyword normally distributed with this mean standard deviation. The masses of the boxes and the cartons are distributed independently to each other. Okay, so first of all, they want us to find the probability that the mass of randomly chosen full carton is more than 3 times the mass of a randomly chosen full box. Okay, right, so let us have a look how to solve this question here. When they ask us to find the probability, so that means P, the full carton, let's say I make the carton as C. C means that the total, okay, all the total, the 20 large packets plus the empty cartons. All right, so it's C, more than, so greater than, 3 times, so times 3, the mass of the randomly chosen full box. So full box, maybe I make it as a B, right? So it will be C greater than 3B. So for this question, they actually want us to find this probability. Okay, right, so before you can find the probability, if I want to find the probability of C greater than 3B, right, both sides with variable, I cannot continue with the calculation. So what I need to do is, I need to change all the variable to one side so that you will have C minus 3B greater than 0. Okay, so when I have all my variable at one side, I can proceed to find the mean and variance for this variable, then continue with the calculation for probability. Okay, so for this question, since you can see all the keywords are normally distributed, okay, therefore we have to find the mean and variance before we can continue to calculate the probability. Okay, so in this question, in general, we already know that it is normally distributed. Okay, so before we start, we need to find the mean first. Okay, so what is the expected value for C minus 3B? Okay, so expected value for C. I think we need to pre-calculate it first, right? Okay, just now we have the variance for the C. This is a variance for C. Okay, so we haven't start calculating the expected value for C. Alright, so expected value for C will be what? Will be the mean for empty carton. So the mean for empty carton is 50. Then plus 20 times of mean for the large packets. So the large packets mean will be 1010. So 20 times. So that means I will take 20 multiply with 1010. And from here, I get the value, which is 20250. Okay, Then if I let C equals to carton, okay, then B equals to box. Now I want to calculate the mean for C minus 3B. I need this mean for this variable because of I want to apply it here to calculate my probability later. Right, so to calculate the mean for C minus 3B, okay, so the mean for full carton is 20250 minus 3 times of the mean for box. So the full box information is given here. It is actually 6730. So 6730. Okay, so from here I get the mean. So what is the mean for this case? So the mean should be equals to 60 if I don't do any careless mistake here. And after that, to calculate the variance for C minus 3B, again, I need to have variance C. So what is the variance for the carton? We already calculated just now in part 1. Variance for the carton is 235.2. Okay, so it will be 235.2. Okay, for any variance, right, with the negative in the variable, there's no negative in the calculation for variance, it will be always a plus. Okay, then the 3 here. For the 3 here, to calculate the variance, I need to look back to the keyword using in this question. So they are saying that full carton is more than 3 times. So the keyword here will be 3 times. 3 times the mass of randomly chosen full box. So you see this keyword 3 times, that means I have only one small box, one box times 3. So when you are having something with times 3, times 2, or times anything, when you want to find out the variance, you have to square the 3. So I'm having 3 squared. Okay, then what is the variance for the box? So the variance for the box is 15 squared. Therefore, I'm having 3 squared multiplied with 15 squared. So I'm having 2260.2. Okay, so from here, I actually know that when I'm having full carton minus the 3 box, they are actually normally distributed because all of them, all the C, all the B, all the large packets, small packets are normally distributed. Okay, so the mean is actually 60 and the variance is 2260.2. And again, like what I mentioned just now, because this question, they want us to calculate the probability of C greater than 3B. And I can't proceed with the calculation if I have both sides with variable. I have to move all my variable to one side greater than 0. Since they are normally distributed, therefore I shall change it become Z. So to change it become Z, you have to standardize your variable. So you're taking the value of the variable minus the mean divided by standard deviation. So divided by square root of 2260.2. Okay, then by pressing calculator, you should get your Z value, which is greater than negative 1.262. Okay, then of course, for our normal distribution table, right, they only provide us the area with the positive value Z. So I have to try to imagine the Z greater than negative 1.262, right? It is having the same areas as Z smaller than 1.262. Okay, so we should proceed further to calculate the probability from this question. So from the table, right? So Z smaller than 1.262, I go back to our normal distribution table. 1.262. So I'm looking for 1.26. Okay, so 1.26 means that they will give me the value 8962 and then 1.262 again. So the 2 here, what do I have is this one. You need to add the 4 at the last digit of this number. So you get 8966. Okay, and the probability will be 0.8966. Okay, so I go back to my solution here. 0.8966 will be my answer. Okay, and of course I will want to correct it to 3 significant figure. Therefore, my final answer should be 0.897. Alright, so this is how we calculate the probability. And of course, when you're having two sides with variable, right, you have to make sure that you move it to one side, then only you can proceed with the calculation. Another small reminder, when you try to calculate the probability, the value of the z here, please make sure that you try to rephrase it correct to, or show your answer correct to 3 decimal place. Because for the normal distribution table, right, the value of z, we can find out the probability up to 3 decimal place. Therefore, during the calculation in this part for the z, we also keep it into 3 decimal place so that we won't miss out any possible area of result. Okay, so this is how we answer question number 5. Okay, so question number 6. A random sample of 5 randomly selected values of a variable x is as follows. So we're having 5 different values here, 1, 2, 6, 1, 8, where a is a positive value, x a greater than 0. Given that an unbiased estimate of the variance of x calculated from this sample is 11 over 2, find the value of a. Okay, so for this question, right, the keyword definitely will be unbiased estimate of the variance. So what is the formula for unbiased estimate of the variance? Okay, so if you have a look here, you can get it from the formula booklet under this part, the sampling and testing, where unbiased estimator. So this is our formula for the unbiased estimated variance. Okay, right, so let's come back to question number 6. Since we already know the formula here, maybe I can show it to you. Okay, so this is the formula for unbiased estimated variance. So we are using S, and then I try to use this one, which is easier for me to calculate. Okay, because we are having all the data here, right? So I'm going to use the highlighted formula here. The variance is equals to 1 over n minus 1. That's summation of x squared minus summation of x squared, the whole thing squared divided by n. Okay, so I'm going to apply it in our question. So the s square here basically will be the 11 over 2. So it will be 11 over 2. Okay, then equals to what? Equals to 1 over n minus 1. So I'm having 1 over 4 because we are having 5 number here, 1, 2, 3, 4, 5. So we're having 1 over 4. What's the value for summation x squared? So the summation x squared is I have to square all the x and then I add them together. So I'm having the first value is a 1, right? So 1 square, then plus 2 square. Second value is a 2. The third value is a 6. So plus 6 square plus 1 square, then plus a square. So this will be my summation of x squared in the formula. Then minus summation of x, the whole thing squared. So when you add all the x together, you're having 1 plus 2 plus 6 plus 1 plus a. You add them together first, only you square them, then divided by the n, which is 5. Okay, so generally, you just need to continue to summarize everything, and you will get the value for a, right? Okay, so let's continue from here. Okay, so 11 over 2, I still remain as 11 over 2. I try to simplify the values on the right hand side here. Okay, so when I'm having 1 plus 2 square plus 6 square plus 1, right, I'm having 42 plus a squared. Then minus, I'm having 1 over 5. When I add 1, 2, 6, 1, I'm having 10. So 10 plus a squared. Okay, then to get the value of a, I try to move the 1 over 4 over, become multiplied with 4. Therefore, my left hand side will become 22. Alright, so for the thing inside this bracket, I will have 42 plus a squared, then minus 1 over 5. I try to expand the bracket here, so I'm having 100 plus 20a, and then plus a squared, and it is equals to 22. Okay, then again, further simplify some more. Okay, so from here, in general, I can see that a is in a quadratic form equation, right? Therefore, I further simplify everything. I will have 4 over 5a squared minus 4a equals to 0 if I further simplify this whole equation here. So this is the term that I have. From here, I can factorize out the 4a, and I get the value a equals to 0, where we are ignoring it because in the question they did mention that a is positive, greater than 0. Alright, so equals to 0 value should be ignored. And then from the second bracket here, I will get a equals to 5. So this one should be our answer. Right, so a equals to 5. Okay, so this question basically is quite straightforward if you know how to apply the unbiased estimator for unbiased estimation formula for the variance. Okay, so this is how we answer question number 6. Okay, so question number 7, which is the last question for this paper. The number of accidents per week. So I think per week is actually one of the keyword to tell us that it is Poisson. But the question also gives us the keyword here. The keyword is Poisson distribution. In the past, the mean has been 1.9 accident per week. Okay, so last year the manager gave all his employees a new booklet on safety. He decides to test at the 5% significance level whether the mean number of accidents has been reduced. So to carry out the test, I think this is an important keyword here. The word reduce help us to form the alternative hypothesis. He knows the number of accidents during 4 randomly chosen weeks. Okay, so the sample that they are taking is based on 4 weeks. Right? So state a suitable null and alternative hypothesis for the test. Okay, so now I want to write out the null and alternative hypothesis. Okay, so since we know that it is Poisson, right, we are going to test the lambda, which is the mean. Okay, when you want to set up the null and alternative hypothesis for Poisson distribution, you can write out the mean for the value given in the question according to the duration. So like this one, we are having 1.9 per week. So you can write lambda equals to 1.9 per week. Or another option is you can actually write out the mean for the duration that or the sample that they use to carry out the test. So for this example, you can see that to carry out the test, right, they actually choose 4 randomly chosen weeks. So if you're having 4 weeks, the mean will become 1.9 multiplied with 4. Okay, so to carry out the test, you can also write as lambda equals to 1.9 times 4, which is equals to 7.6 for 4 weeks. So you're allowed to write out either one of them. Okay, you can write it out in the basic per week one, the basic lambda for 1 week, or you can write out the lambda for the 4 weeks that they are going to use to carry out the test. Okay, then to form the alternative hypothesis, again, the keyword will be reduce. So reduce means it should be smaller than, right? So this is again another one-tail test, but this one-tail test is on the left. Right, then or you can write lambda smaller than 7.6 for 4 weeks. Okay, so how I know it's smaller than? Because of the keyword reduce. Okay, then after that, we want to find the critical region for the test and state the probability of a type 1 error. Okay, so keyword will be to find the critical region. Okay, so to find the critical region, before we start, right, maybe you need to try and observe first. This is a one-tail test on the left. Okay, I just simply draw this diagram, and then I know that there's a certain area on the left, it will be my rejection region. So I actually want to know how big is this rejection region. Okay, I want to know what's the number of x is actually inside the rejection region. Okay, so let us start to calculate it. For this rejection region, right, it is actually our significance level. So this whole area is 0.05. The area is 0.05. Okay, so to carry out the test, I will want to start calculating the probability of x smaller equals to, by right it should be start from 0 Okay, x equals to 0, then x smaller equals to 1, x smaller equals to 2, and so on. So that I want to know where should I put my value of x when I'm having 1 is the one in the rejection region or is the one outside the rejection region? So this is what I want to test and find out. Okay, usually we will not start from the 0 because 0, it is quite sure that it is inside the rejection region. So maybe I will want to try my luck, but I will start with x smaller equals to 1 first to save a little bit of time. Okay, so to calculate x smaller equals to 1, the formula will be e negative lambda. So for the lambda that we are using should be 4 weeks one. Okay, for 4 weeks, sorry. Okay, so for here I'm using the lambda for 4 weeks, it will be 7.6, and then the first value is always a 1, the second value is always a lambda. So the first value is for x equals to 0, then this one is for x equals to 1 when you multiply with e power negative 7.6. Okay, so for this value, if you try to calculate it, you will see that the value that we get is 0.00430. And if you try to compare it with our significance level, which is 5%, so this area is still smaller than the significance level, right? So what does it mean basically? So when you're having x smaller equals to 1 equals to this value and smaller than 0.05, it actually means that my x equals to 1 falls under the rejection region. Of course, the 0 also falls under the rejection region, so 1 also the same. Okay, then now I want to continue to test for x smaller equals to 2. It will be e negative lambda 1 plus lambda power 2 divided by 2 factorial to calculate the area for x smaller equals to 2. And then if I try to calculate it, I'm having this answer 0.0188. Compare it with the significance level, it is still smaller than 0.05. It actually means also that x equals to 2 also falls under the rejection region because the area for smaller than 2 is less than 0.05, right? So that means the 2 here basically still inside the rejection region. Then how about for the next one? So for the next one, I'm going to calculate x smaller equals to 3, e negative 7.6. So this is for x equals to 2, then for x equals to 3, it will be 7.6 power 3 divided by 3 factorial. And again, if I try to calculate the value from this part, I will get 0.0554. And if I try to compare this one, right, it will be more than 0.05. It means that the area for x smaller equals to 3 is already more than 0.05. So when you want to label the 3, it falls under the acceptance region. Okay, so from this diagram, you can make a simple conclusion where the critical region or the rejection region, you need to list out the value for the x. So you can see that the rejection region is for x equals to 0, x equals to 1, x equals to 2. So you can write out as x smaller equals to 2. This will be your rejection region. Some students say, can I write x smaller than 3? Also can, right? Not including the 3, right? So x smaller equals to 2 or x smaller than 3, not inclusive of 3. Okay? Yeah, so usually for me, I will try to imagine a simple diagram like this. But of course, in exam, we don't need to show this. Okay, because this is not a correct graph for the Poisson or binomial. But it is just for to visualize it. Alright, I want to find what's the value for the x that falls under the rejection area. Okay, so after I find the critical region already, so what is the type 1 error? They are asking us to find the probability for type 1 error, right? Okay, so how to calculate the type 1 error? Okay, so to get the type 1 error, the definition is reject the null hypothesis given that the null hypothesis is true. So reject null hypothesis means the rejection region. Okay, and then null hypothesis is true means that when we calculate the value, we are using the lambda equals to 1.9 or 7.6. So reject null hypothesis means rejection region. So what is the probability for rejection region, which is smaller than 2? So the rejection region here is 0.188. And this 0.0188, I'm using the lambda equals to 7.6 to calculate out this value one. So basically the Taiwan error is already appeared in our calculation just now, which is equals to 0.0188. So you can just straight away state the answer. Okay, so this is our part number 2. Alright, then let's have a look for part C. Okay, so for part C, they are asking us what is the meaning of Taiwan error in the question context. Okay, so of course we cannot just write out a general definition where Taiwan error is reject the null hypothesis when null hypothesis is true. Okay, so we have to rephrase it in the sentence that's related to the question. So we actually conclude that reject the null hypothesis. So we conclude that, okay, so again, we go back to our question here. If I reject the null hypothesis, means that I conclude that the lambda is less than 1.9, right? That means the number of accidents has been reduced. Okay? And when we want to write it out here, we conclude that the accident, the mean number of accident has decreased or has reduced. Accident has reduced, although it is not. Okay, it is not means that actually the null hypothesis is a true one, but we conclude to reject it. All right. So when you reject it, it means that the mean number of accident has reduced, although it is not reduced. All right. So this is how we explain the error in the question context. Okay. Then after that, for part number D, during the 4 randomly chosen weeks, there are a total of 3 accidents. State the conclusion that the manager should reach. Give a reason of your answer. So now for the 4 randomly chosen weeks, right, they say we are having 3 accidents in total. So what's the conclusion that I should make? Okay, then now we should try straight away compare the 3 with the rejection region that we get. So you can see that the rejection region that we get just now is x smaller equals to 2, right? So if let's say the number of accident is 0, 1 or 2, then we will reject the null hypothesis. But for the part D, our x is 3. So you can see very clearly that 3 falls under the acceptance region. Therefore, when 3 falls under the acceptance region, we will not reject the null hypothesis, right? So 3 is not in the rejection region. It is in the acceptance region, so we actually do not reject the null hypothesis. This is a conclusion that we can make. Okay, so 3 is not in the rejection region is the reason. Okay, then the conclusion is do not reject the null hypothesis. So the conclusion would be here. Alright, so this is how we answer part D. Okay, so when we say do not reject the null hypothesis, you can further explain by writing out the conclusion in question context. So there's no enough evidence to show that the number of accident has decreased. Okay, right, so this is how we conclude. Okay, we make a conclusion by using the number of accidents provided. Alright, then now let's proceed to the last part. Okay, for part E. Now they want us to assume that the mean remains the same, which is 1.9 accidents per week. So use a suitable approximation. So highlight this keyword, approximation, to calculate the probability that there will be more than 100 accidents during a 52-week period. Okay, originally we are having Poisson distribution. And then we want to find out the probability by using approximation. So in our syllabus, right, there's only one where we can change the Poisson become normal distributed. Okay, so we will start the calculation here. Originally, I know that my XL is Poisson distributed, and then it will be 1.9. The lambda is 1.9 per week. But for our question here, they are changing the duration become 52 week. 1.9 is for 1 week. Therefore, to calculate the lambda for 52 weeks, I have to take 1.9 multiply with 52. So from here, I get a very large value, which is 98.8. So when I'm having a large lambda, I can change it become normal distributed, okay, where the mean is 98.8, the variance is also 98.8, because for Poisson distribution, right, both mean and variance are having the same value. And then what is the criteria that help us to decide we can change the Poisson become normal? When your lambda is greater than 15, then generally you can change the Poisson become a normal distribution. Okay, and then before we calculate the probability, we need to further investigate. For Poisson distribution, it belongs to discrete random variable. And then for normal distribution, it is actually a continuous random variable. Therefore, later when you want to calculate the probability, we have to apply continuity correction. Okay, so I want to calculate the probability that the number of accidents is more than 100. Okay, so this one is before the continuity correction. So after the continuity correction, it should be x greater than 100.5. Okay, so if let's say you don't know how to decide it, then basically you can try to list out all the possible value first, 100, 101, 102. So when they mention greater than 100, that means that I want to start from 101, right? I want to calculate the probability, start from the value 101. So for the continuity correction, we want to make it slightly earlier than the area that I want to find, or the probability that I want to find. So this value is actually 100.5. Right? So after you decide the continuity correction already, then you can proceed with the calculation for probability. Again, now we are having it as a normal distribution, therefore you have to standardize it become Z. Okay, so for the standardization, it will be 100.5 minus the mean, then divided by the standard deviation. So divided by square root 98.8. Okay, again, try to find out the value of Z correct to 3 decimal place. So you're having 0.171. Then to get this area, you need to find it out from the normal distribution table, right? Okay, so we go to our table, looking for the area. Z smaller than 0.171. So this is 0.1. Maybe I can use other color. Wait, okay, so let's say this is 0.171. So 0.171 will give you this value, 0.17 and then 1. So that means you have to add 4 into the last digit of 5675. So if add 4, you will have 5679. And this area is actually, or this probability is actually Z smaller than 0.171. So if I want to get the area that's more than 0.171, you have to take 1 minus the probability that you get just now, which is 0.5679. And after you find out the value, correct the answer into 3 significant figures and you should get 0.432. Alright, so this is how we answer this question. Okay, and this is the last question already. So we have finished discussing all the questions in this paper. Thank you very much for watching this video.